Well, hi, and thanks for joining me here in my shop this morning. What day is it? It's the 23rd of August. Another beautiful day outside. Holy smokes. Getting very cold overnight already around here. It's a little bit surprising. So, I've glued the cartridge in place and I've added a little extra weight. Now we're going to find out what it really amounts to, and then, assuming this all is good, it's all going back in the cabinet for another real world test. Did I say that right? So just tuck the wire up in there a little bit. Take off our temporary grip. There it is. Not coming out. No. 20 years from now, if this is still around and if it's actually worn down, somebody's going to go to replace that cartridge and they're going to have a surprise. Okay. Let's see what we get here. The moment of truth. Now, I've put the cartridge back in. I did use the Lego piece. I inserted that little battery I used as additional weight in there. So it's in there. What do we get? What do we get? 2.6. Whew, that's light. 2.6, and it's only going to get lighter as I measure it lower. Wow, that's a little light. That's probably a little too light. Is there some way of doing this? Maybe not. Yeah, I don't know if that's valid. 2.5. It's always 2 something. I think that's too low. 2.8, pushing 3. So I'll follow the same process again. I'll leave it as it is. It's easy to add weight. Just stick things up underneath until it weighs the right amount. Better to have it light than heavy at this point, that's for sure. We're in a much better starting place. So I think that's good to go. Oh, by the way, on the last video, while I was remarking about how great it sounded on the how great this player sounded on the video, it may have been distorted since the levels were a little high going on to the video recording itself. So you might have been hearing distortion while I'm commenting about how wonderful it sounds, and you're kind of wondering what's going on. It's because my headphones that I was listening to are actually plugged into the soundboard, so I'm not really listening to what is ending up on the YouTube video when I do that. So that's just a little production issue for me. And hey, put it all back into that cabinet. Where's the cabinet? There it is, just sitting there waiting. It's hungry. Okay, I will do that. We're almost ready to try out the entire stereo system here behind me, but first, for those of you who are trying to do like I do, I don't recommend, don't do what I do, okay? One of the things I did was I left my very nice Foot and Cold Water record on the record player while I worked on it. And now I have a big blob of epoxy on the record there. So, any chance that can pop off? No. So I ruined this record. I completely ruined this record. I managed to get it on one of the best tracks on the record. Is there any chance this stuff will pop off? There's no chance at all. Just don't even bother trying, Jim. What's the use? She's done. So I ruined my record. So don't do that. You know, and I dripped that stuff on that record 2 seconds after the thought crossed my mind I should remove the record from the record player. That's another interesting thing about how our minds work. So I saw it coming, and then I did it. Okay, on to better things now. Okay, I think we're ready to give this guy a go, and we'll see what happens here. Didn't have the power on. There we go. Just give it a moment to warm up. This is the non-glued side of the record here. Okay, so I'm not likely to get a hit from that. Because I don't know if you could hear it, but the record was skipping all the way across. So, you know, that's an indication that it's too light up here. So I think that's enough for the record player right now. I've got a couple other things to attend to get this guy finished off in here. So we'll worry about the weight a little later. The main thing I'm concerned about now is the lack of tweeters, and let's see what we can do about that. You know what? We'll just test them again using the FM receiver here.
In his daily rounds of administrating her husband's
I actually like the hiss.
Nobody else was there, and she...
That's good.
This man.
She grabs hold of his coat and she says, if you won't go with me, I'll
Drag you into the bedroom.
Well, I'm pretty sure there's nothing coming out of the tweeters at all. Now, is that because the tweeters are shot? These are electrostatic tweeters. I've never done much with them. So, son of a gun. I have to think about it a bit. I guess we could look to see if the signal is actually reaching the tweeter, if the voltage that it requires is reaching it. And what to do about that, I don't know, because I'm pretty sure this just comes straight off the output transformer straight to the speaker. Okay, got to think about that one a little bit, but we're really close here. Fantastic. I played the FM stereo. I didn't put it on video because I wanted to play it fairly loud and play some music, which I know will garner me a copyright hit. It sounds fine. The bass response on the record player is not the greatest. And of course, we heard it skipping. We know it's too light. So I'm going to find a weight I can increase it with. So that's 4 grams. I'm looking for something around 3 grams of weight. That's 1.5. And something in the middle. 2. No, 3. So that's 3.2. So it's 2.9, 3.2, and it's going to give me roughly 6 grams. Probably a touch heavy. Let's see what it sounds like this. Okay. Oh, just realized you may have had a hard time hearing me there the last little bit. Because I have a microphone set up right here. That you're listening to, so sorry if that last part was just a little bit on the quiet side. There. It's not tuned well. So with the record player or the console on this angle in my shop, that station is hard to receive. If I rotate this just 30, 40, 50 degrees, it comes booming in. So, you know, directional antennas are a problem in stuff like this. Big problem. So let's get this guy going here. Manual. Yeah, I don't know how to make this go on manual. Let's try this. We'll put this like this. Okay, with the overarm there, the record player will think, or should think, it's dropped a record. No. There's the switch. You can hear it. Yeah, it's coming down too far. So most record players, the overarm is held up high enough that the record player thinks it's dropping records. Not this one though. So this is a tricky one. You must drop the record. And just another thing about these overarms, as attractive as it is to lift them by the front part here, it's much better to reach right back and grab them by the post back here and move them. That's a good, you can stick your finger under, but way at the back here. It's just a little bit of a better deal. Now this, I'm going to hopefully just plop on top like that. And I'll put it on after it starts playing, because it's bound to fall off during that. Oh. Okay, word on that is placing this on it and taking it off. I could hear no tonal change in the sound at all. But I'm pretty sure that without this extra weight, this thing is going to skip badly. Now the player is on a bit of an angle here. I haven't got it perfectly level, and that's a big deal, because if there's any propensity for the needle to jump, for instance, if you're dancing around in your living room shaking this thing, you really want the needle, if it's going to lift up, to fall back into the same groove. If you've got it on a bit of an angle, it will fall on the angle. It just doesn't take much, because we're talking about, you know, fractions of a millimeter of movement. And so in that case, when you start dancing on your floor, the needle will just go right across the record. So, you know, level's important, everything's important. On the sound quality, it hasn't got the highs. It's not going to have the deep bass. The reason for this is that this is a rim drive record player, and so its ability to reproduce bass from the record without reproducing the rumble from the record player is kind of impossible. So they do their very best, but they restrict bass in these kinds of record players. So even the cartridge is not necessarily producing the full bass sound that you know is there on the record. Because it's going to pick up the motor rumble too and just transmit it through the speaker. So these rim drive record players are inevitably restricted on the bass side just a little bit. The treble side, it doesn't seem to be very sharp and crisp. It's certainly listenable. There's no distortion, so it's quite listenable. But the bright highs are not there. Again, maybe it's just the cartridge is just not going to do it, or I don't know what else it could be, really. I think it's got to be a restriction coming right from that cartridge. Certainly when you play FM, you get the deeper bass and you get the higher treble. And the last thing is the speakers themselves are not reproducing the treble the way they're intended, because the tweeters appear to be not working. So we'll look into that a little bit, but like I mentioned before, I'm not sure what I can do about it. I have not done much with electrostatic speakers, so this is a first for me. And where would you start? I think I would start by reading up on electrostatic speakers. That's what I'll do. Hey, let's try the off switch. Still working. Great. So I said so much about the record player inside this console. Let me show you another record player. I happen to have this one in from another console, but it's the next level up. So you can compare it very quickly. So let's do that. So here it is. I just tossed it on my bench here. So the first thing that sets this apart from the other record player is it's not using a spring to adjust the balance weight. It's using a counterbalance back here. So once you see a record player with a counterbalanced tone arm, you know you've gone a level up. And generally what they're trying to do is make the tone arm suitable for a magnetic cartridge. A cartridge with a much lower output but much higher fidelity, but it cannot track at a heavy weight. So the ceramic cartridges, like on the other record player, are tracking 4 or 5 grams, somewhere in there, maybe heavier. And the magnetic ones, you're going to want to track them, you know, if you get down to it, 1.5 grams, maybe 2 on an older one, somewhere down like that. Then that goes to needle wear and record wear, and so you get higher fidelity while reducing the amount of record wear by simply lightening this thing up and using a cartridge which will work under those kinds of circumstances. So now once you put the magnetic cartridge in, you have at your disposal an opportunity to produce high fidelity out of here, which would be very low bass and very high. So the low bass begins to introduce the problem of transferring motor rumble from the motor into the cartridge. So the first solution used by these manufacturers was to continue with the rim drive, but try to get the rumble down. And part of that was, I'm going to get this out quickly. No. Part of that is developing a motor with extremely low rumble. So it needs to be absolutely balanced, because as you can imagine, the motor is spinning around in there. If there's a slight imbalance, that will cause a shake, which will cause a hum-like sound, which will be transmitted. And the motor's turning at a pretty high rate. I don't know what rate. So that hum is actually not so deep. It's a little higher. And then there's also all kinds of rumbles in here. In a cheaper version, and I guess somehow they've managed to reduce it. On the motor side, what I wanted to say was they advertised this record player as a laboratory series record player. And what that means is during the manufacture of the motor, they moved it into a laboratory environment in order to better balance the rotor in it. So yeah, it's just more factory, of course, it's more people, more factory, but that's a stage that may not be done in other motor manufacturing, where the motor is just all the parts are put together and it is what it is. I think there's always some attempt at balancing a motor. What they're trying to say here is that they put a lot of effort into reducing the rumble, so you can use a very sensitive cartridge and therefore get nice bass coming out of your speakers. So this particular console is a level up in all respects from the one I'm working on behind me right now. So, and this guy, I'll be focusing more on this one coming soon. And by the way, this is the one with the overarm that's way over. It's over here doing its thing. It should be over here doing its thing. So that's what's got this one. That's what's got me scratching my head on this. So I just wanted to show you that and really draw attention to the difference between these two record players here. Because at a glance, they look the same. At a glance, you wouldn't think there's some difference between them, but keep your eyes peeled. If you're out looking for stuff like this, look for something with a counterbalance on it. Okay, so I read up on tweeters in these older European-style radios, the Electrostatic tweeter up here. And although it was a different speaker, the comment was typically there are contact problems inside the speakers that end up interfering with their operation. It's very unlikely that we can hear something coming from this speaker and there not to be a signal on the end of this wire. So I think I'm going to take this one out and we'll take a look at it and see what we can see about it. It's pretty easy to take out. So that's the plan. Get it on the bench and we'll see what's up with it. Okay, so I've got the speaker out here, and very, very simple construction. There's a metal grill here. The metal grill is held in this plastic housing with these metal tabs, 4 tabs just bent over. One of them is soldered here to this ground shield. The other lead is connected in through here. Now apparently this is where the problems start. making the connection between the wire coming in and the moving diaphragm, or the diaphragm that's supposed to move inside here, is tricky business. And apparently that's where the failures occur. So don't know if that's the case with this one. So what I'm going to do, you see it's still wired up. I'm going to turn the set on. I'm going to be able to put this right up here. Let's see if you can see that. We got the camera. Yeah, so you can see the microphone. I'll be able to hold it like this. You'll be able to hear it. We'll be able to double check whether there's any sound coming out of here. I'll also be able to flex this connection a bit. See if anything happens. So in order to make this really work well, though, I don't want to be playing records. I don't want to be fighting with getting copyright hits. So instead, I'm going to make use of this instrument here. This is like my own little FM transmitter. Well, it isn't like it. It is. It is an FM transmitter. And so I'm just going to set it up to produce a signal with 1,000 hertz coming out of it. So we should hear a 1,000 hertz tone once I have it received on the receiver. So it runs at about the center of the FM dial, about 100 megahertz. So let's switch on the record player. Is everything okay? Record player, the receiver rather. Let's switch that on. Here. Power. There we go. You can see the light come on if you're watching carefully. I'm going to tune it on FM to around 100. Here. There it is there. I have it tuned in really well. But 1,000 hertz is not enough. You gotta go up. 5,000. That's 5,000. Even 5,000 may not be enough. My next step up, unfortunately, is 19,000, and we're not supposed to hear that. So we'll try it with 5. We'll see if any of the 5 is coming out of that little speaker. It's a little bit tricky here. I'm going to use my ear first of all because, well, I'm familiar with my ear. Ooh, stuck my ear right on it. No, I don't hear a darn thing. You know, I think the flat on the speaker here is reflecting the fan sound in my computer over yonder. If I hold it just right, I'm just imagining it. Okay, now with the speaker in here going, it's a little tricky to hear this one. I'm going to just move it up and down from the microphone, and I'm going to watch the sound level on the microphone. Better yet, I'm going to put my headphones on. I hear what you're hearing. That's a better idea. Well, there's an interference thing happening there. What's happening there? I've got a magic hand. Okay, let me wiggle the wire here. Ah. So I hear some crunchy sounds. Clicks and pops. So it must be the case that there's a lot of standing waves and things like that going on in the air around the big speaker there, and as I move my hands around, I'm changing the pattern of these standing waves, and occasionally the null is hitting the microphone and it's just funky stuff. I think we can be pretty sure there's nothing coming out of this. Hey, what if I just move the microphone away from down here? That's a good idea. I can go up here. This is get out here. We'll go out here. Don't fall over everything now. So it's still on camera. You can see what I'm doing. Yep. Okay, so I got a little less. You know, I'm hearing the tone not through the headphones. I'm just hearing it through the air here. It's really very confusing. There we go. Lots of crunchy sounds there. Certainly don't hear treble popping to life. Let me try it. Now, there should be like a couple hundred volts between here. Danger, Jim. If I touch both these, that's a serious thing. Don't touch that. I'm telling myself here. Well, is this some kind of let's turn off. Let's turn this off here. Or can I possibly get a higher tone? Let me just double check. See if we can go higher. Well, that's 19. That's plenty high. You know, it is possible. It's possible for me to get a higher tone on here, but I'm going to have to hook up more equipment. Here, take a look. So if I feed an alternate audio signal in here, flip this to external AF, I can then use this signal generator, the one up above it here, to produce the audio. And this can produce any frequency I like. Let's set that up, see if we get that going. The reason for doing this is because I read that these tweeters are essentially silent below their starting frequency, which is somewhere typically, at least in the article I read, somewhere around 7,000 hertz. So we're running with 5,000 hertz and I'm not hearing anything. I don't think I've proved anything yet. So let's try this. Okay, so the tone you're hearing right now, see, as I move around in the shop, it's going to fade in and out. It's being transmitted from here to the receiver. So I'm affecting the signal as I move around a little bit. The tone you're hearing is coming from this signal generator here. And just to be sure, I put the scope on right at the point where the signal is injected into the transmitter here. So this should allow us now to select any frequency we want to send over there and hear what comes back. Now, another thing I've done here, let me swing this around. Let's see if we can get a shot of it. A little awkward to see, but here's the other microphone, and here's the speaker. Kind of down below the speaker box. So if anything comes out of that speaker, we should be able to hear it on that microphone, and I'm going to, I see it's faded out again. I'm also going to cut off the microphone that's right here in front of me. So now all we're hearing is that microphone I showed you. Okay, so the current frequency is about 1,000 hertz, and we're going to jack it up. We're going to jump up. Jump up, I think, to 10,000 hertz. Good luck. Let's see if we hear any of it. Okay, so pretty sure now there's a 10,000 hertz signal being sent. I'm not hearing anything. 10,000 is a little high, but let's stick with this. I'll raise the level being sent here. That's interesting. There it is. input level. This is doing pretty much the same thing this is doing. So I don't know why, I don't know, we have to analyze this for a while, what's going on inside the FM radio deck. It's just heard when I crank this up. Let's see if we can get the tone to show up though. We'll take it down from 10, take it down to 9. When can you hear it? Oh, I can hear that. That's 8. I hear that. Now the question is, where are we hearing it from? So, well, let's fiddle around with that arrangement. So I'm thinking the sound is coming out of the main speaker, but I don't know for sure. So I'm going to move that speaker around and we'll see if the sound changes. And of course I've got headphones on now. Everything has a limit. The microphones, the headphones, everything has a limit. Yeah, I'm not hearing that tone through my headphones at all. But I certainly hear it in the room. So I don't know what you're hearing. You may not be hearing any 10,000 hertz tone, but I'm hearing it. Okay, 9,000, 8,000 hertz. I'm sorry, it's at 8,000 hertz tone. I think what this is really showing is the tweeter is not tweeting at all. So there's a couple ways of approaching this problem. Let me bring this mic up here. Turn that one down. The one you're looking at. So what's possible here is to install typical tweeters in here. Forsake the electrostatic circuitry entirely and just throw in a couple of standard sort of tweeters, smaller speakers, and just hook them up to the same wires that drive the big speakers, and maybe whip a capacitor in there and try to keep the bass away from the little speaker. That's an alternative. I think there's more to do with these speakers yet, because this is such a common problem. I'd really like to go just a little bit further with it and see if we can figure something out. When I look at those tweeters, they look like you can do nothing about them. That's what they look like. Nothing at all. So I've cut out the speaker here, and if I bend these tabs back, the front plate is going to drop off, I think. Let's try that. This is not working as it is, so this last one has the soldered on tab, so this one may not come right off, but I think we can get this out and bent away and get a look at it. Oh, the whole thing's coming out. The whole unit here. Hey, hope there's no charge left in it. If I start singing tweetery sounds. Okay, there we go. So the idea is here, this is a plastic film, and on the back of it, it's metallized. And then the metallized film and the grate together form a capacitor around the plastic. You want this thing, you don't want all these parts kind of rattling around in there, so somehow this has to be pushed against this very uniformly. And I'll bet you we're going to find some foam under here that's supposed to do that. Now, this must be the connection point. Yeah. Oh, hey, well, there we go. That was quick. There's the foam. Take this out. Oh my, look at the contact. It's a spring. And you know, this foam, like almost all foam, you find in these radios. There's a piece here. Look at, there's nothing left of it. Let's just get it out of here. I can't even grip it. Oh boy. The easiest thing in the world. Pick that up. Oh, this is so flimsy. Oh my gosh. Holy smokes, this is flimsy stuff. Not the foam. Yeah. Wow. There it is. So, once again, the idea is this. Oh, I don't want to touch it. With the plastic side. Wait a minute, which side's the plastic side? Like this. That's an extremely thin film. How thin is it? Holy smokes, man. Let's just take it out again and take a look at it. You see the light right through it. Uh-oh. Uh-oh. Mother-in-law's calling. Hello? Okay. Just turn off a few things here before I forget. Just to review the construction. The objective is to push the plastic side of the metallized plastic sheet here up against this in some fairly uniform way, but not so hard that it can't move, because it has to move. So the choice was foam. Foam is obviously a good choice. Looks like they put holes in the foam here to let the sound through or something. I mean, obviously if you put too stiff of a foam in here, then the little diaphragm's not going to be able to move, or its movement's going to be restricted. And if you don't do enough in here, this thing's going to be flopping around. It's going to kind of rattle or buzz or do something. The next problem is the contact here. This just looks like routine copper wire. It's springy. Maybe it's copper plated steel, because you need something like steel to make a spring. Then that's in contact here with this material, which has got all these funny colors all over it. Now what I think is going on there, we're looking at the metallized side, and the metal in here has been reacting with various gases that are in the air, maybe even gases coming from componentry in the radio itself, in the receiver. That's not a good sign. That just shows that what was probably a beautifully conductive metal surface when they first made it is now covered with thin corrosion products, which are probably not conductive. And the last thing is the contact point between here and here. You can see it. You can see the round circle. If I'm going to guess, the metal is gone. That through some kind of interaction, the metal is gone from there. There's no more contact. This could be as simple as just rotating this to a new contact place on here, and then I have to establish the foam somehow, or some foam-like material. Surely very thin foam, just like what they've used here, is the ideal thing. So I think there's a chance this can be fixed to make it work again. Wow, 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 wow. What's on the other side of this? Nothing. Well, I got something wrong here. This is coming down. Oh my gosh, there's only a couple of parts here, Jim. How can you get it confused? Oh, I kind of thought that might happen. So we've broken the tab off. So we're down to 3 tabs, and these, when I bend them back, if I bend them back, there's no unbending them after that for sure. I've consumed the goodwill on bending those things at that point. This guy's supposed to sit like this. Oh, that's the spring part here, pushing back. So that's sitting like that. It's held in place by the same 4 tabs coming from here. That's all. I just now 3 tabs, which is going to be a problem because one tab missing is a problem. Well, I'm going to think about this. I think there's a low chance I can restore these. Never done it before. I'm sure there's ways of doing it. Don't know that this material is functional anymore. I can't even be absolutely sure that the receiver is delivering the proper signal to the speaker. I think it kind of has to be. I think a better alternative is to put in a standard tweeter. I think that's a better alternative. Well, I'm going to see what I got. Maybe I got a couple of good ones. I'll see. Okay, so when it comes to small speakers, I don't have a lot. Yeah, that's a real McCoy tweeter there. Goodness knows if it works. I've only got one. I've got a whole bunch of these little teeny, well, 4 little teeny guys here. And it looks like 2 sets of pairs. Let's check these out and see what they sound like. I have no idea if these are suitable for using in this kind of situation here. Let's get the signal. So I'm going to drag these straight from the output of my signal generator, which probably has enough to make these guys work. Let's find out. There we go. What does this sound like? Oh, I hear something already. This is 8,000 hertz and almost 0 output. Let me turn it up. Oh yeah, that's a screaming. That's great. Let's go up in frequency. Well, I'm having trouble hearing it. Let me turn it up. Oh no, it's still there. That's 10,000 hertz. That would be 11,000. That says 10. Okay, that's okay. This is 10,000 hertz. That's 2,000 hertz. Let's see if I can. It's a little tricky getting this. Here we go. That's here. Maybe you can see the numbers changing there. .7 kilohertz. Funny sounds come out of that little speaker there. 10. That's 20 now. We don't want to do that. We want to do this. Let's take it up until we can't hear it. That'd be a good way to do it. Until I can't hear it. Right in that area there. That's 12.5. Let me put a little more juice to it. Now, you know, or what are we hearing? The limit of my ears. There's lots there. I'm encouraged. Let's try another speaker of exactly the same type, and then I'll see if I have actually a useful pair. So I'm just hooking it up here. Eight ohm, 0.2 watts. I don't think there's a short there. Let's try it. Now this is 12. I can hear something. 12, we'll take it down. Whoa. You can certainly hear a response curve like that. Down around 5 or 6 it really comes through. That's fine too. So let's try these slightly bigger ones now. 8 ohms, quarter watt. Okay, here we go. It's the same. Fades out the same area. Maybe it's just, you know, the limits of my hearing. This got more volume though. I mean, it's a bigger speaker. It's got more volume. And I have 2 of these. Let's check the other one out and see if there's a pair. Screw hitchhiking on that one. I think it makes sense to put these in. And you just make a crossover, you know, just using a capacitor is probably enough. So we're at 14 kilohertz. Let's go down. There it is. About the very same place, 12.5, where I really can't hear it anymore. Great! Okay, I think this is the way to go for sure. Whoop, whoop, don't go away. Where are you going? Everybody just fell over. That's the way to go. So the next stage here, I think, would be experimenting. So I want to set it up so I can have one of these functioning, and I want to be able to vary the crossover. And I want to be able to hear this distinct from the other speaker, and I want to be able to supply varying frequencies, which I can do with my FM transmitter. So I think I'm all set here to experiment and find out if this really does add quality to the sound coming out of that stereo. And I got to think about this a little bit. Oh, you know what? It's lunchtime. Yeah, that's good. Lunchtime. So just before we carry on with the speaker stuff, I haven't had this magazine out in my house for no good reason. I have a bunch of these old magazines like this, usually on the shelf. I think I pulled this one down to use as a surface or something like that. And I noticed something kind of funny about it. This is published 1979 by the American Radio Relay League. So 1979, I was in college. Well, that's what I noticed. This guy, he's got my tools. But not only that, and I'm afraid I can't pull it out and show it to you, I had exactly this soldering iron, I believe. It's exactly the same kind of light bluish color I think I had exactly the same soldering iron too. So anyway, no other reason to show you that other than the funny coincidences that can happen in life. Now, I thought of an issue about the speakers here, and that is I'm thinking of just tapping off the speaker signal that reaches the big speaker and feeding it maybe through a capacitor to one of these speakers for the tweeter. How do I know for sure that the tweeter sound is there to be tapped off? This is going to a mid-range speaker, something about this size here, something very much like this. For all I know, the receiver, or the receiver's designed so that the tweeter sound never goes to that speaker. So there's nothing for me to get and send to one of these there. Or is there? I'm not sure. I'm not even sure how I'm going to figure that out easily. And secondly, in thinking more about this, I realized some of my earlier experiments where I was feeding tones or a tone of different frequencies through the FM transmitter and into the receiver. Well, there's limits there that I didn't think about. I mean, you can only send a certain pitch through an FM transmitter. I think it's around 15 kilohertz, and beyond that, it's not going to work at all. So, anyway, I don't think there's any reason to stop here. We keep going, but I have to take sort of a step-by-step kind of experimental approach to this, and just make sure what I think is true really is true. That's tough these days. Okay, I think we're ready to go now. So what you're seeing on the screen there is a microphone. Let me just turn that. Okay, so you're not listening to that microphone at all. You're just listening to a single microphone that I'm speaking into, a little ways away from the setup there. And that little speaker is not operating. You can see the yellow clip lead's not hooked up to anything, but it's ready to be hooked up. And what you're listening to is just the sound coming out of both sides of the console, the regular speakers that are built into it. You're listening to 1000 hertz tone generated by by a separate signal generator fed into the FM generator, just as I did before, and just over 1000 hertz in fact. And for those who are aficionados of FM, the deviation is about 40, maybe a little under 40 kilohertz right now. Okay. So what I plan to do, well, we're just listening only to this microphone here. I turn the speaker on and off with the clip lead and see what we hear. This is a fairly low frequency right now, and I don't know what we're going to hear. Let's see. So it's all about experimenting. So. Okay. Well, that's pretty interesting. Let me, I'm not listening with headphones, but just with my ears. That was interesting. Let me put the headphones on. Well, that was actually very, very revealing, because just before I turned the cameras on to do that, I had noticed that if I turn the signal level, the FM signal generator, the FM carrier level down, then the radio becomes a little bit hissy, of course. And I thought, oh, that hissy would be interesting stuff to have it come through, because that's the high frequency stuff. That's really what you want the tweeter to respond to. So with the 1000 hertz tone, you really don't want to hear that. I didn't really hear it, I don't think. What I heard was all that hissy, crackly stuff. So that's great. So what we want to do now is just listen to that speaker. I'm going to raise the frequency up, and we'll see if it reproduces a high frequency that the bigger speaker is not able to reproduce. And with no capacitor or anything, just right on there. So we're at 7 kilohertz now. So this is the point, according to what I read, at some random website, that generally the crossover takes place. Okay, so at 8,000 I could hear it. I just switched it up to 9,000 kilohertz. No, 9 kilohertz. And I can't really hear it. I still have headphones on here. Let me just listen with my ears. Okay, well, there's something there, but for crying out loud, it's so weak. Now, I don't know about the level of the signal I'm feeding into it. So what we're trying to really determine here is there any high frequency stuff on this, on the feed to the regular speakers? Or is it somehow not there for who knows what reason exactly? But it would be desirable for it to not be there, and that's why I'm concerned. It's desirable to somehow make all the high frequencies go to the tweeter only. So maybe they've engineered that inside this receiver. It's not that difficult. A crossover of some sort. The only difference is this is done with an electrostatic speaker, and the sound signal that goes to the electrostatic speaker doesn't even go through the output transformer. So how it all works exactly in the end, I don't know. How could we figure this out? How could we figure this out? Precisely. How could we figure this out? Yeah. I don't know. I've got to think about it some more here. Okay, so I smartened up a little bit. I've cut out the FM transmitter side of things. I now have a piece of wire going into the tape input on the receiver, coming straight from the signal generator. So is that going to make things sound different? I doubt it. So we're going to put the frequency generator up here. Okay, that's 10. Oh, I don't hear a thing. Now let me turn the volume up on the receiver. So I turn up full, I hear something coming from somewhere. You know, that could be a tube making that sound for all I know. Okay, so I've got it turned down a little bit. Let's hook this guy up and see what happens. Okay, so it's a stereo unit. I'm feeding one input. Maybe I'm feeding the wrong channel here. Maybe. Yeah, let's. I'm gonna figure. Okay, hang on. Okay, hold on. Let me just figure out what's going on here. Hey, here I am again. What's going on? Okay, so I'm going to cut this short at this point because I become convinced that the sort of mid-range type speakers that are in there are reproducing these high frequencies just as good as the tweeter's going to, probably a lot better. I'm not going to get any advantage from trying to put these little tweeters into this guy. So I think we're just about at the very end here.